Here, looking at the forces acting on this will be the direction of velocity. This will be mg. Mg will be perpendicular, and if you look at from some other angle, clearly this will also be perpendicular. So all forces now perpendicular to velocity vector. So now though this implies dv naught at t equals 0. Component and perpendicular to radius. See, at any given time we'll have something of this form intuitively. This will be v along t cap plus u along n cap, and n cap is normal. Velocity vector can be written like this. Acceleration vector will come out to be dv by dt along t cap plus v into derivative of t cap by dt plus du by dt along n cap is u into derivative of n cap just equal to dt. But at t equal to 0, dv by dt is 0 and u is also definitely 0. So our acceleration comes out to be v into dt cap by dt du by dt along n cap. Now we have to find the du by dt. First we'll concentrate on this term dt cap by dt. I have to tell what is the meaning of that, right? If it was at here, this will be the direction of t cap. After some small time interval, this will be the direction of t cap. So let this be some small angle theta or small angle d theta. This will be 90. This will be horizontal. This will be d theta, so this will be 90 minus d theta. So this angle should be d theta as well. So from here I can see that these both are equal. And this is d theta. dt. This will be the direction of dt cap dt cap. Change in dt cap vector. This will be the change in dt cap vector, and since these two are 90, like equal, the angle is in such a way that angle will suggest that the angle made with this vector was what? 90 minutes d theta, and the angle, this angle will also be 90 minus d theta. That is from the triangle thingy. So this one and this one, by this line the angle is same. This implies parallel lines. Therefore, the dt cap by dt is basically minus r cap. So this is nothing but basically n cap. So that is a proof that is n cap. So acceleration vector basically along n cap, not equal to this thing, but it's basically along n cap. And this one though definitely is along n cap. Now how do you find this derivative of t cap with respect to time? So this one was known as derivative of t cap with respect to time. How do you do that? Well, for that you can use geometry. So again, from this triangle, this is t cap. I made a lot of mistakes here. T cap. This triangle, t square plus t square minus t cap square to t square cos theta, cos of d theta. This implies dt cap whole square is 2t square 1 minus cos d theta. This implies dt cap is 2t cap, wait, 2t, just 2t cap, cap. Everywhere just put mod. So mod t cap sin d theta by 2 this is one d theta. Therefore dt cap by dt is d theta by dt. So this term is basically v into omega, and omega is equal to v by r. So this term is v square by r. Now coming to du by dt, this will be some distance L, this is by, this is by L. So this endpoint is equal to a naught, r square plus y square is equal to L square, which is a constant, to r dr by dt is to y dy by dt is 0. This implies dr by dt whole square plus rt square r by dt square plus dy by dt whole square by d square by dt square is 0. This is 0 initially, 0 initially. This is nothing but du by dt, and this is a naught. From the diagram, another thing is clear, that is when this is theta t equals 0, r is equal to L sin theta, L cos theta. So I can tell that L sin theta du by dt minus L cos theta into a naught du by dt minus a naught cot theta. Now but what does this minus mean? Yeah, so sorry, I made a mistake here. That is minus dr by dt is u. Since u is causing this r to decrease, we are supposed to put minus dv by dt, minus dv by dt. So dv by dt will come like this. So therefore, acceleration vector simplifies to acceleration vector will simplify to v naught square L by sin theta plus a naught cot theta.